Hey folks, welcome back to Precalculus. Today we're wrapping up Chapter 6, Section 3, okay, where we're going to be combining what we did in 6.1 and 6.2 with verifying identities along with 6.3 with what we learned about sum and difference identities, okay, and stuff like that. So the first example, we're diving straight into examples. We're just verifying, which means we're going to work on one side of the equation here. We're looking for the most difficult side, so I'm going to choose the left, and I'm going to notice right away that these look like sine family sum and difference. Just to refresh, you guys have these on the front of your 6.3 notes, but there is the sine family. Sine of an angle plus an angle is equal to that. Sine of an angle minus of an angle is equal to that. So we're going to make a simple substitution in hopes that it equals 2 sine x cosine y. So the sine of an angle minus an angle is equal to sine of the first angle cosine of the second angle minus cosine of the first angle, sine of the second angle. Now all of this right here is just sine of x minus y, plus sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. We hope that that equals 2 sine of the first angle times cosine of the second angle. Well, if we look at it, we have some like terms here. We have a negative cosine x sine y and a positive cosine x sine y. So those are going to be canceling each other out. And if we look right here, we have a sine x cosine y and another positive sine x cosine y. So 1 sine x cosine y plus 1 sine x cosine y is equal to 2 sine x cosine y, which is exactly what we were hoping for. So a nice little two-step verification. Okay, let's keep on going and let's try another one here. So you may be a little bit tempted here to say, well, the most difficult side looks like it's the right side. But if I'm looking at it, I'm saying, well, these both have singular x's in them, a coefficient of 1 in front of all of the x's. And I know what to do with those. Those look familiar to me. Whereas this cosine of 3x, I don't really know how to do that. Okay, so this is actually the more difficult side, even though it's the shorter handwritten side. Okay, but we know that cosine of 2x can be written as, or I'm sorry, cosine of 3x can be written as cosine of 2x plus x. Okay, now I'm going to go through, I'm not going to rewrite this right side the entire time. I'm just going to show you how this is eventually going to equal cosine cubed minus 3 sine squared times cosine. Okay, now this is a cosine family sum and difference identity. Okay, if we recall, cosine family is right here, is equal to cosine of the first angle times cosine of the second angle minus sine first angle sine second angle. So let's go ahead and do it. So it's going to be cosine of the first angle times cosine of the second angle. You can already see I'm getting a cosine x out of this, which is really good. Okay, obviously that's one of the things I'm aiming for. Okay, now minus sine first angle sine second angle. First angle is 2x, the second angle is x. Okay, so now look, sine x popping up. So we can see we're kind of getting to where we want to simply by splitting our angle. So why not just do it again? This right here is cosine of x plus x. And this one right here is sine of x plus x. So we really have cosine of x times another cosine family identity. Okay, so I'm going to rewrite this cosine right here where I got my pencil in front, just for organization purposes. And then this cosine of an angle plus an angle, I'm going to use my cosine family identity again. So that's going to be cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. And you see now we've got all kinds of cosine of x's, sine of x's, which is what we want. Okay, minus, and now we're going to dive into this piece right here. I'm gonna write this sine of x first, just for organization reasons. And this sine of an angle plus an angle is equal to the sine of the first angle times the cosine of the second angle plus cosine of the first angle sine of the second angle. Now, if we look at it, let's just start simplifying and let's just follow some basic algebra. Okay, this is going to be cosine squared, so we have cosine of x times cosine squared x minus sine squared x. Sine times sine is sine squared. And then right here we're going to have minus sine squared x cosine x. All I did was distribute this sine to this first term. And then notice this first term and this second term are really the same thing, so I'm going to distribute my negative sign to that as well. So we'll end up with another minus sine squared x cosine x. Now if we distribute this cosine in, let's go ahead and do that. We're going to end up with a cosine cubed, which is very good because that's one of the things we were aiming for, minus, and then we have a cosine times a negative sine squared. So negative sine squared x cosine x, and we still have our other negative sine squared x cosine x's here that we just won't touch for one step. Now if we look at it, cosine cubed can't be simplified, but we have a negative sine squared cosine, another negative not sine squared cosine, and another negative sine squared cosine. So we have a total of negative 3 sine squared cosines, which is exactly what we were aiming for. So we just verified that cosine of 3x is equal to cosine cubed minus 3 sine squared x cosine x. Okay, let's keep going here. Let's keep going. Now, picking a side to verify this identity, you might be tempted to go right side, but this left side is just jumping out off the page saying sum and difference identity for tangent, which we can reference our equation sheet. Get the glare off there for you. Right here. The tangent of an angle plus an angle is equal to all of this. Tangent of an angle minus an angle is equal to all of this. And you guys know how to use the plus or minuses and minus pluses. So that's all we're going to do. So the tangent of an angle plus an angle. So this first one, I'm going to put it in giant brackets for you guys, is equal to tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first angle, tangent of the second angle. Now this tangent of an angle minus an angle, I'm going to put right here in brackets because we got to multiply them together, is equal to tangent of the first angle minus tangent of the second angle over 1 plus tangent first angle times tangent second angle. Now we're hoping, I'm just going to show, I'm not going to rewrite this right side yet, but we're hoping that we eventually equal this, okay, on the right side. So if you look at it, look at the top. Let's multiply across the top. And we have tan x plus tan y and tan x minus tan y, which we notice right away are binomial conjugates. And when you multiply binomial conjugates, you get difference of squares. So square the first term, tan squared x. Difference means subtract. Square the second term, tan squared y, which, look, is exactly what we wanted it to be. Now let's look at the bottom. 1 minus tan x tan y and 1 plus tan x tan y. So we notice we got binomial conjugates again. Anytime you multiply binomial conjugates, you're going to get difference of squares. So the first term squared is 1. Difference says multiply. and square again the second term, so that'd be tan squared x times tan squared y. And without doing all the foiling, you're welcome to do it, but you see right away that this is equal to this, which is exactly what we wanted it to be. Okay, let's keep on going. So look, what looks like we have a little bit of a difficult one here, but it's actually going to end up being a little more simple. So we notice right away we have cosine of an angle minus an angle, and sine of an angle plus an angle is equal to 0. We're trying to verify still. Okay, so clearly we're working on the left side, and our sum and difference identities should be jumping off the page at you. Okay, we're going to be using our cosine and our sine sum and difference identities here. Okay, now cosine of an angle minus an angle is equal to, all right, over here, cosine of the first angle times cosine of the second angle plus sine of that first angle times sine of that second angle. And then we have to do plus sine of an angle plus an angle, which is going to be sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. And somehow that's got to equal 0. Okay, well, let's look right away. Cosine of pi. We know that. That's -1. So we have -1 times cosine of x. Sine of pi is 0. We all know our unit circle. Sine of pi is 0, so sine of pi times sine of x is just going to be 0. Sine of pi halves is 1. So really this term right here is 1 times cosine of x. And then the last one, cosine of pi halves is 0. 0 times sine is still going to be 0. If we look at it right here, we have negative cosine. And right here we have a positive cosine, which we're going to cancel each other out. So we end up with 0 equaling 0, and we are verified. Okay, let's dive into another one here. All right, clearly we should be in the groove now where we're recognizing that this is cosine sum and difference identities. So we want to use those family of identities to prove this right side. Okay, so let's just go ahead and make the substitution. Cosine of an angle plus an angle is equal to cosine first angle, cosine second angle, minus sine first angle, sine second angle. Now, cosine of an angle minus an angle is equal to cosine first angle, cosine second angle, plus sine first angle, sine second angle. I'm not going to write it out right now, but obviously we need to get that to equal cosine squared x, sine squared y, okay, which it does not. But looking at this, we're like, oh, okay, again, we're visited by our good friends, the binomial conjugates. And when we multiply binomial conjugates, we get difference of squares. So we're not going to have a middle term. It's simply going to be this thing squared minus this thing squared. So cosine squared x times cosine squared y minus sine squared x sine squared y. You want to FOIL all this out, you're welcome to do so on a scrap piece of paper, but this is what it's going to simplify to. And I'd be happy to show you that in class if you're unsure. Okay, so now we're looking at this and we're saying, okay, cosine squared x, that's what I wanted. And there it is. So I don't want to mess with that. I certainly don't want this cosine squared y. So we got to think, is cosine squared y equal to anything that does not have a cosine squared y in it? Because that's something we don't want. Well, if we remember our Pythagorean identities, cosine squared y is equal to 1 minus sine squared y. which happens to have a term in it that we want. So let's go over here to the second term. Sine squared x, sine squared y. We want this sine squared y, so I'm going to keep it. But we don't want this sine squared x. It's not in anything. We're looking at our crystal ball. We're looking at the right side. We're not touching it, but we're looking at it. We don't want this sine squared x. So let's make a substitution for sine squared x. Well, we know that sine squared x is equal to 1 minus cosine squared x, which happens to have something in it that we need. So let's go ahead and simplify all this out. You end up with cosine squared x times 1, which is cosine squared x, minus cosine squared x sine squared y, just distributing, that's all I'm doing, boom, boom, minus sine squared y times 1, and then negative sine squared y times negative cosine squared x is going to be positive cosine squared x sine squared y. And if we look at this right now, we're saying, oh, look, we have a negative cosine squared x sine squared y and a positive cosine squared x sine squared y. So those things are going to be gonzo. And we're going to be left with cosine squared x minus sine squared y, which is exactly what we wanted. It matches exactly the right side of our identity. Okay, let's dive right into this last one of the day here. So we're looking at it and we see on the left side again our sum and difference identities for sine, the sine family. So let's go ahead and use those to verify that it's equal to the right side. Okay, because we know exactly right off the bat, well, we can plug in right there. So sine of x plus y, I'm going to start over here on the right to give myself some more space, but is equal to sine of x cosine of y plus cosine x sine y. That's what sine of x plus y is. And on the bottom, sine of x minus y is equal to sine of the first angle times cosine of the second angle minus cosine of the first angle times sine of the second angle. Okay. Now, I know you're tempted. You see some sines over cosines and stuff like that, but remember, we can't simplify. We can't just start canceling things or anything like that because we do have this plus sign and this subtraction sign in our denominator. Okay, we have to have factors of the entire top and entire bottom. But if we do some detective work, and I'm going to show you guys a new strategy. Okay, sine x cosine y. We really need that to be tangent of x. That's what the goal is. And and so on and so forth. Cosine x sine y. We need that to be tangent of y and so on. You can look at the bottom as well. So whatever we do, we have to do to the whole thing. We have to do the same thing to the whole thing. Okay? But you have to be clever and see, okay, well, how can I turn sine of x cosine y into tangent of x? Okay, so let me rewrite that, just that term. Sine of x cosine of y. Well, if that was divided by cosine of x, you can see right there, there's the tangent of x. That matches exactly what we want. But I need this cosine y to be gone, so if maybe I put cosine y. Then that would cancel and give our tangent of x that we're looking for. But we just divided by cosine x cosine y. So we got to check and see, does that work for every other term? So let's go over here. We originally have cosine x sine y, and we want to check and see if dividing by cosine x cosine y is going to work out. Well, our cosine x's will cancel out, and we're left with sine y over cosine y, which is tangent of y. Okay, well, let's check the bottom here just to be sure. Everything should work out. The bottom we had sine x cosine y, and we're trying out dividing everything by cosine x cosine y. Well, there's our tangent of x right here. Cosine y is canceling out. Our last term to check out on the bottom was cosine x sine y, and remember we're dividing everything by cosine x, cosine y. Well, our cosine x's would cancel out. Sine over cosine of y is tangent of y. So we could see that we end up with tan x plus tan y over tan x minus tan y, which is exactly what we were trying to verify. Okay, simply dividing every single term by the same thing is no different than multiplying the top and bottom all by the same thing. It is definitely an algebraically legal move and one that we now know how to employ. So thank you very much, guys. I look forward to helping you in class. Make sure you show up with questions. Have a good day.